What happens when we discover a star that defies our understanding of the universe? The VY Canis Majoris, the largest known star, has left astronomers with more questions than answers. On one hand, its enormous size is awe-inspiring. On the other, it challenges our current models of stellar evolution. The VY Canis Majoris' size is unsettling because it defies our intuitive understanding of stars. At first, that number sounds absurd, over 2,100 times larger than our Sun. But when you consider that a star like this would consume the entire solar system, including all the planets, and still have room to spare, its enormity starts to make sense. This star's sheer scale raises questions about its life cycle and eventual demise. What would be the consequences of such a massive star collapsing? Would it produce an explosion powerful enough to affect nearby celestial bodies? The more we learn about VY Canis Majoris, the more we realize how little we understand about these cosmic giants. The VY Canis Majoris, a star so massive it defies logic. That number sounds absurd until you realize its implications. If it were to go supernova, it would engulf our solar system. The sheer scale is mind-boggling. Yet what's truly fascinating is the fact that it doesn't fit our current understanding of stellar evolution. Its size suggests a star in its final stages, but its core temperature is unexpectedly high for someone expecting imminent collapse. Some theories propose it might be a product of binary mergers, but even those can't fully account for its enormity. The more we learn about VY Canis Majoris, the more questions arise. What exactly triggers such extreme growth? And what does this mean for our comprehension of star formation and death? The VY Canis Majoris star, with its mind-boggling size of nearly 2,100 times that of our own Sun, raises more questions than answers about what big even means in astrophysical terms. That number sounds absurd until you realize it's not just a simple scale up. The laws of physics, as we understand them, start to break down at such enormous sizes. The surface gravity would be so weak, it'd be challenging to maintain any kind of stable structure. It's as if trying to build a skyscraper with an exponentially increasing number of floors, each one stretching farther and farther into the atmosphere until it becomes unstable. So, what does it mean for our understanding of star formation? Does VY Canis Majoris represent an extreme case, or is there still more to discover about these gargantuan objects? The discovery of the largest star ever recorded has sent ripples through the scientific community. That's because it fundamentally challenges our understanding of stellar evolution. This behemoth, roughly 2,100 times larger than our Sun, defies conventional wisdom on how stars form and grow. The sheer scale is mind-boggling. I must admit, that number sounds absurd until you realize this star likely formed from a massive cloud of gas, rather than the typical smaller core. But what does it mean for our understanding of these celestial bodies? Was it always growing at this incredible rate, or was there some cataclysmic event that triggered its expansion? The truth is, we just don't know yet. And that's precisely what makes this discovery so intriguing. It highlights the complexity and mystery still surrounding stars, even after centuries of observation. One would expect that by now we have a comprehensive theory of stellar evolution, but it seems we're still pushing against the boundaries of what we thought was possible. The discovery of the largest star ever recorded challenges our understanding of how these massive celestial bodies form and die. With a size roughly 1,500 times larger than our Sun, this behemoth is rewriting the textbooks on stellar mechanics. That number sounds absurd until you realize that it's not just a matter of scale, it's about the fundamental laws that govern the behavior of stars. We've long assumed that there's an upper limit to a star's size, beyond which it simply can't sustain its own gravity. But what if this gargantuan star is forcing us to rethink our assumptions? What does it mean for our understanding of stellar evolution? And where does this leave us in terms of predicting the life cycles of stars like our Sun? The discovery of VY Canis Majoris, nearly 6 times larger than our Sun, has left astronomers scratching their heads. That size difference sounds absurd until you realize it's not just about scale, it's about what that says about the fundamental building blocks of stars. See, most stars form from a disk of gas and dust that collapses under its own gravity. But VY Canis Majoris defies that model. Its enormous mass likely formed through some other process we don't fully understand yet. Some scientists propose it could be the result of a merger between two smaller stars, while others suggest it might have started as a massive cloud of gas that just happened to collapse in a more extreme way. What's most striking, however, is that if VY Canis Majoris were placed at the center of our solar system, its surface would extend beyond the orbit of Mars. That's a mind-boggling thought, not because it's unprecedented, but because it so thoroughly upends our expectations about how stars are supposed to behave. The VY Canis Majoris has been touted as the largest star ever discovered, but let's take a closer look at its dimensions. With a radius roughly 2,000 times that of our Sun, it's easy to get lost in the sheer scale. That number sounds absurd until you realize what it actually implies. If VY Canis Majoris were placed at the center of our solar system, its surface would extend beyond the orbit of Saturn. Now, imagine a star so massive it warps space-time around itself. But here's the thing, we're not entirely sure how massive it is, or even what it really looks like. Its size is an estimate based on observations from afar, and there's ongoing debate in the scientific community about just how accurately these measurements can be made. As we continue to study this enigmatic star, one question lingers. What secrets lie at its core, and will they unlock new insights into the nature of stellar evolution? The discovery of VY Canis Majoris raises more questions than it answers about our understanding of galactic evolution. That's because its sheer scale contradicts some of our long-held assumptions about star formation and death. I've spent years studying the life cycles of massive stars, and this one defies conventional wisdom. At over 1,000 times larger than our own Sun, VY Canis Majoris challenges our theories on how such behemoths come to be. We've traditionally thought that stars like these are born from smaller precursors, but VY's immense size suggests a more complex origin story. The implications for galactic research are clear. If we're wrong about the formation of massive stars, what else might we have misunderstood? And what does this mean for our understanding of the cosmos as a whole? The phenomenon of mass loss in massive stars has long been a subject of fascination and debate among astrophysicists. And for good reason. A star like VY Canis Majoris, which we're studying here, is shedding its outer layers at an alarming rate. That number sounds absurd until you realize that it's actually not about the quantity of mass being lost, but rather the implications it holds for our understanding of stellar evolution. See, if stars can lose such a significant portion of their mass and still manage to maintain their structure, it raises questions about the fundamental forces at play within them. What does this mean for our theories on nuclear fusion? Can we really trust the models that predict how these behemoths will behave under extreme conditions? And what about the potential for dark matter? Could it be influencing the mass loss process in some way? These are just a few of the questions that make VY Canis Majoris such an enigmatic and intriguing subject. But as we delve deeper into its mysteries, one thing becomes increasingly clear. This star is not what we thought we knew. When we talk about turbulence in the context of stars, it's easy to think of it as just a minor detail, a bit of chaotic motion here and there. But that's not what we're dealing with when it comes to the largest star ever discovered. The sheer scale of this thing is mind-boggling. I mean, 2,100 times bigger than our Sun? That number sounds absurd until you realize it's actually not that far off from some theoretical models of what these supergiants could look like. And yet we're still struggling to understand how they form in the first place. See, simulations suggest that turbulence plays a crucial role in the process, but the data is still patchy and inconsistent. It's almost as if we're trying to grasp a handful of smoke. The more we think we know, the more it slips through our fingers. The discovery of VY Canis Majoris poses an intriguing challenge to our current understanding of nuclear fusion. That star's size is measured at around 2,100 times larger than our Sun, a number that sounds absurd until you realize the implications. For decades, we've relied on the Lawson criterion as the benchmark for stellar stability, but VY Canis Majoris defies those predictions. Its enormous size should, theoretically, create immense gravitational forces, causing it to collapse under its own weight. Yet, somehow, it maintains a stable equilibrium. That raises questions about our grasp of nuclear fusion processes and whether there are other factors at play that we've yet to consider. Ultimately, this enigma highlights the limitations of our current knowledge and encourages us to re-examine our understanding of stellar evolution. VY Canis Majoris's past remains shrouded in mystery, and it's precisely its enormous size that fuels our ignorance. With a radius roughly 4 times larger than our own sun, we'd expect to find some hint of its history etched into the galaxy's records. Yet, the more we learn about VY, the more questions arise. Take its estimated age, 8 million years old. That number sounds absurd until you realize it suggests that this behemoth was already massive when our own solar system was still in its infancy. How did it manage to grow so gargantuan without drawing attention from the cosmos? The silence is deafening, leaving us to ponder. What celestial events triggered VY's explosive growth? And what secrets lie hidden in its ancient past? When we say that VY Canis Majoris has been deemed the largest star ever discovered, it's not just about its sheer size. That number sounds absurd until you realize what it actually means in astronomical terms. We're talking about a star roughly 2,100 times larger than our own sun, with a radius that would engulf all 8 planets in our solar system. But here's the thing, as massive as VY Canis Majoris is, its core remains shrouded in mystery. What lies at its center? Is it a swirling vortex of nuclear reactions, or something entirely different? Theories abound, but one thing is certain: the more we learn about this behemoth, the more questions we're left with. And that's precisely what makes VY Canis Majoris so fascinating. It challenges our current understanding of stellar evolution and forces us to confront the unknown. The discovery of VY Canis Majoris, with its unfathomable size, raises more questions than it answers. That number sounds absurd until you realize the implications it has on our understanding of stellar evolution. If a star can balloon to such an enormous size, what does that say about the limits of nuclear fusion? Does it challenge the conventional wisdom that stars have a finite lifespan? We're still grappling with these fundamental questions, and VY Canis Majoris only serves as a stark reminder of how much we don't know. And yet, as intriguing as this find is, it's hard not to feel a sense of discomfort. The sheer scale of this star makes it almost impossible for us to wrap our heads around. What does that say about our own understanding of the universe? The discovery of VY Canis Majoris as the largest star ever recorded has left us with more questions than answers about our understanding of the universe. That number sounds absurd until you realize it's not just a matter of scale, but also of implications for our current theories on stellar evolution and the life cycle of stars. If we're being honest, this finding challenges our notion that all stars follow similar patterns of growth and decline. But what does it say about the universe as a whole? Are we dealing with anomalies, or are these anomalies the new norm? The truth is, we still don't fully grasp the underlying mechanics driving the behavior of celestial bodies like VY Canis Majoris, and this revelation only serves to highlight our limitations in understanding the vast expanse that surrounds us. And yet, as scientists continue to probe the mysteries of the cosmos, it's clear that there's still so much we have yet to uncover. Join me next time as we explore more fascinating stories from the world of astrophysics and discover how they're changing our understanding of the cosmos.